A couple things that we need to know about. Some vocab words. First one being experiment. Some process that occurs with well-defined outcomes. Probably in Algebra 1, you did like flipping a coin. Did the probability of getting the heads or probability of getting the tails? That's the experiment. And the outcome is the result from the single try. So if you said, what is the probability of getting the heads from a flip of a coin, and you get a heads, then that's your outcome. You can look at the probability more than once. So you might have a collection of one or more outcomes. That's an event. And then the collection of all of the outcomes of the experiment is the sample space. So when we look at this here, the basic definition of probability, it looks like that. And the first thing that I see when I look at it is it looks super complicated, and that's something that I either need to really, really stop and read, or I need to let my teacher give me maybe an abbreviated version. But I do want to read it in terms of the math. It says the probability of an event occurring is given by the ratio. So the P parentheses E means the probability of the event equals the number of the event divided by the number of the sample space. I think is that, and let me say that again. The N parentheses E is the number of outcomes that fall into the event, and NS is sorry, I just don't see that, the number of outcomes that fall into the sample space. Well, how can I say this a little bit better? The way that I learned probability is it's the way that something happens out of a total. That's how I think of this. The NE is the way that something happens, and then the NS is out of the total ways that it can happen. One thing that I started down here that's really important is that all probabilities must be between 0 and 1. And that conceivably is going to be a question on the OST test. As we look at the first example here, which of the following cannot be the outcome of a probability? Well, 100%, it can. That's the one. 1 or 100%. Could be every single time. 2/3, is that between 0 and 1? Yes. 3/2, is that between 0 and 1? If you convert it to a decimal, this is 1.5, and that's not between 0 and 1. So which of the following cannot be is that one. 0.75, again, is between 0 and 1. So if you're not very good with the fractions, use decimals, use your calculator to determine the answer there. So here is a better example to kind of look at our vocab and the basic definition of probability. We are given a spinner that has 5 equal sectors, and the first question is, what is the experiment? Well, what we're going to do, it says the spinner is spun. Well, what is the experiment? We're spinning the spinner. That's the experiment. That's how we're going to get some answers here. The sample space. Well, what are the possible answers that we can get? We can spin and get a 1. We can spin and get a 2. We can spin and get a 3. We can spin and get a 4. We can spin and get a 5. So that's our sample space. So if we look at one of the outcomes here, it says give one possible outcome. Well, pick one of these numbers. It doesn't even have to be the same thing that I write down on my paper. It's either 1 or 2 or 3 or 4 or 5. I'll go right in the middle. One of the outcomes. We spinned and we ended up with a 3. It landed on the 3. But here's the probability here on part D. What is the probability of landing on a prime? Well, first of all, we need to refresh our memory with regard to prime numbers. And a prime number means that it only has factors of 1 in itself. So if you need to write that down, only has factors of 1 in itself. That's it. So now that we know that, when we look back up there, and we look at number 1, well, the number 1 is 1 times 1. So technically that is not considered to be prime because the only factor that it has is 1. 2 is 2 times 1, and that's it. So 2 is considered to be a prime number. 3, the only factors are 1 times 3. 3 is considered to be a prime number. 4 has 1 times 4, but it also has 2 times 2. 4 is not prime, but 5, only factors that 5 has are 1 and 5. So there are those in terms of prime. And then again, when we think about probability, well, what is the probability of landing on a prime? We can land on a prime 1, 2, 3 ways. And we have a possible total of 5 ways. By the way, I'm not sure why, but sometimes the OST likes this in terms of decimals. So there is the ratio, but we can also convert this, and I'm fine with the fraction, but we could also convert this. So you can take 3 divided by 5 on your calculator if you prefer, and you get 0.6. Next, if we flip our paper over, we've got the test results of 88 students are recorded in this two-way table below. Use the table to answer the following. So first of all, before we answer the probability of getting an A, or the probability of a student being male, or the probability of a student being female, often what we like to do is we like to total things up. It sometimes can make things a little bit easier on here. So what you can do is you can simply extend this line here, extend this line here, and then we're going to extend here. It's going to be a tight squeeze in here, and actually we can even go over here if we wanted to, and I don't think that that's absolutely necessary. But if we take a look here, what we want to do is I'm going to start with the males. Well, we have 15 males who get A's, 20 males who get B's, and 13 males who get C's, and if we add those up, we get 48. Same thing if we look at the females. We had 12 females who ended up with an A, 19 who ended up with a B, and 9 who ended up with a C, and if we add those up, we get 40. Also going here in terms of the A's, we had a total of 27 students get A's. We had a total of 39 get B's, and we had a total of 22 to get C's. And I wish I wouldn't have written in red, but I did. If we extend this down, what should happen here is when we add 48 plus 40, we better get 88. And if we add 27 plus 39 plus 22, we still better get 88. In this particular problem, we were given that there's 88 students there. So that should simplify things just a little bit here when we look at this. Again, when we're answering these questions, it says the probability that A occurs. The probability that a student got an A. Well, we had 27 students who got an A out of a total of how many students? Well, out of a total of 88 students. If we look at that decimal approximation, all that you're doing is you're taking 27 divided by 88, and again, I am fine with the fraction, but roughly we get 31.31 or 31% of the students got A's. Because oftentimes when teachers are analyzing, that's what they look at. They look at a percentage. 31% got A's. Well, the next question says the probability that the student is male. Well, if we look, how many total male students do we have? Well, we totaled that up a moment ago. We ended up with 48. And how many total students do we have? We have a total of 88. By the way, you could simplify that fraction if you wanted to. You do not have to. Again, if we take a quick look at this, it's going to be 48 divided by 88 gives us roughly 0.55, which is 55%. And then finally, on this part C, oh no, we have part D as well. Probability that that a student is female. Well, how many females do we have? We have 40. We did that total a little bit ago. And out of a total of how many students is the 88. And if we type that in, which I'll not type in, I'm just going to type in, I get 0.45, which is 45%, by the way. And actually, these are approximate values because we had to round a little bit. So really, approximation, we do two squiggly lines for the approximation. Again, I'm fine with the fraction. So now if we look at part D, it says, if only a male is chosen. So we're only going to look at the male. And that's going to be, when we get down here, that's going to determine our denominator. That's going to be the total in this case. So we look and what we see is we've got a total of 48 male students. And then the question says, well, what is the probability of picking a student who got a C? Well, we come over here to our C column. You're only looking at the males now. And there are 13 males who ended up with a C out of a total of 48. If we type that into our calculator, we get approximately 0.48, which is 48%. A little bit more vocab. Set. A collection of things, numbers, objects that satisfy a well-defined criteria. Elements are the things that are contained in the set. And then a subset. Any set whose elements are all contained within another set. And the vocab is good here, but I think that it shows up better in an example than it does by me talking a little bit about a bunch of words. So if we look at example 4 here, it says set A is all the numbers greater than 0 and less than 10. And so it says write out all the elements of set A. Well, if we take a look at this, we're going to say A equals, to identify that we're working with set A, and then all of the numbers greater than 0. So 0 is not going to be a part of it. So we start filling them in. Notice that I did not write 10. It says all of the elements greater than 0 and less than 10. So there's our set A. Well, now it says given set A. So now we're going to refer back to set A. From example 4, And then we want a subset of B. So we're only looking at what's in A to determine what are B, what's going to be part of B. It says we want only, a subset B is defined as all of the odd numbers from set A. So when we look up at number 4, is 1 an odd number? Yes. 2 is even. 3 is odd. 4 is even. 5 is odd. 6 is even. 7 is odd. 8 is even. 9. So our subset. So once we've determined the set, then we're taking elements from that set to make up our subset, which is going to be 1, 3, 5, 7, and 9. One final topic, complement. A complement is all the outcomes that are not in an event. In other words, the complement of an event is all the other outcomes, the ones that we do not want. We often associate the complement of an event with the word not. It sounds more complicated than it is, but when you look at here, just a little example, it says when an event is landing on heads, the complement is landing on tails, because it's not heads. When an event is rolling an even number, the complement is rolling an odd number. Again, what's not even? Something to keep in mind here, and maybe even star that one as well, like we did, that all probabilities are between 0 and 1, is that all probabilities are between 0 and 1. The probability of an event and its complement will always add to 1 or 100%. So as we flip our paper over to finish here, it says the probability of rain tomorrow is 40%. So what is the probability of not raining tomorrow? Well, if 40% is, then 60% is not. And if you want a mathematical equation for that, what you did is you took 100% minus 40%, and there's where the 60% came from. We look at number 7. A spinner is created with 3 equal sections. An experiment is run where the spinner is spun twice. So the first part is write the sample space and call this set A. So if we write the sample space and we call this set A, be very, very careful in terms of listing them, because you want to go in order on these. So what happens is the first time we spin, we get 1. But then the second time we spin, we could get a 1 again. Oftentimes written as an ordered pair here. Well, we could still the first time get a 1, but then the second time we might get a 2. We could spin and get a 1, and our second spin could get a 3. The process continues. We could first time get a 2, the first spin, the second spin get a 1. We could get a 2 on the first spin, and we could get a 2 on the second spin. We could get a 2 on the third spin and a 3. Sorry, 2 on the first spin and 3 on the second spin. We're doing 2 spins, and we're listing out all the possibilities that can occur here. We could get a 3 on the first spin and a 1 on the second spin. We could get a 3 on the first spin and a 2 on the second spin. We could get a 3 on the first spin and a 3 on the second spin. There's all the possibilities with that spinner. And it's not the most fun thing to write it down, But if you can write it down in a logical order, then it's going to make answering the questions a lot simpler. And that might be something that you want to write down on your scrap paper that you're given when you're taking the OST. But now it says set B is the spinner landing on doubles. So here we're looking kind of at a subset. So set B is the spinner landing on doubles. Well, what are our options here? Write all the outcomes. Well, 1, 1 was a double. And 2, 2 was a double. And 3, 3 was a double. And what we want to do is we want to find the probability of B. Well, probability of B. We've got 1, 2, 3 ways that we could get a double out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 ninths, which is approximately 0.33, which is 33%. Again, I'm fine with the fraction. If you happen to convert that 3 ninths to 1/3, that is fine also. And it says, find the probability of not landing on doubles. Well, if the probability of landing on doubles was 0.33, then the probability of not landing on doubles is going to be 100% minus 33%, which is 67%. I actually did do the 1/3 here, which is the same thing as 3 ninths. So if there's 1 out of 3 ways that we can land on doubles, then there must be 2 out of 3 ways that we cannot land on doubles. That's the complement. When you see that word not, and that's something that you might want to circle to indicate that even when we go back here on this one, what is the probability of not raining? Because that's when you're looking at the complement. To finish here, on a sheet of stickers, there are 20 gold star stickers, 10 silver circle stickers, 15 silver square stickers, and 5 gold diamond stickers. Owen picks a gold sticker. Which of the following is the complement of this event? Well, think about your 2 options here. You're picking gold, you're picking silver. So it says, which of the following is the complement of this event? So we want to not pick a gold. So if we're not picking gold, then that means that we need to pick silver. And there seems to be some miscellaneous information in there because we've got the 20 gold star stickers. We've got the 10 silver circle stickers. But really what's important in this information is that you're working with either gold or silver stickers. And so it says, which of the following is the complement of this event? Since he picks a gold, the complement is not picking a gold, which would mean that he picks a silver. Lastly, a former OST question, again, would not be surprised if it shows up on this year's OST, but it says an online retailer conducts a random survey of its customers. The survey shows that 80% of the customers receive their purchases within 4 days, and 95% of those customers are satisfied with the quality of their purchase. It says what percent of all customers receive their purchases within 4 days and are not satisfied with the quality of their purchases. So here's the thing. Look at what we've got. We've got 80% of our customers receive the purchase within 4 days. And it says of this 80%, 95% of them are satisfied. But the question says, which of them are not satisfied? So if they're not satisfied, 95% of those are. What's our complement of 95? It's going to be the 5%. And it says what percent of all customers receive their purchases within 4 days and are not satisfied with their purchases. So what we're going to do is we're going to take this 80% and we're going to multiply it by its 5%. When we're dealing with percents, remember you can put in a decimal place. So this is really 0.80 is what 80% is. And 5% is 0.05. We're moving our decimal 2 spaces to the left. So if we pull out our calculator or we pull out decimals and we do 0.8 times 0.05, we will get 0.04. And again, that's in terms of decimals. If we convert it back into a percent, that's 4%. We move our decimal 1, 2 spaces back to the right, and I kind of covered it up in terms of our answer. But I think this one says 4%.